Okay, we are ready, right? Okay. First question. First question again. Let's start the ball rolling with. Let's start with Jethro. Number one, if you're asked to approximate the gradient at 1.5, do you remember what do we do? Yeah, right. So to estimate f prime of 1.5, we are going to use f of 1.6 minus f of 1.4. Right. This is how we do the approximation. Oops. Right. Okay. So this is how we actually approximate f prime of 1.5. Okay. Let's have Gary. How do we approximate f prime 1.2? 1.2 we use, right, so this is approximately f of 1.4 minus f of 1.0 over this question doesn't ask for say f prime of 1.6. Let's hear from Jaira. If you have to approximate this, what would you do? Brilliant. Yep. Right. Right. If you're ever asked, okay, that is number one. Okay. Question number two. Chimaya, are you ready? Yeah, it's your turn. B, is it? B. Okay, you have chosen B. How did you come to this conclusion? Okay, so first and foremost, Chimaya check for this, whether or not this is true. He checks for whether or not this is true. Okay, let's see again. Chimaya, tell me, how do you compute f of 2? The 2x plus 2, right? And therefore, this gives you 6. How do you calculate this limit? You must calculate the left limit using this function. And to calculate the right limit, you use this function. And both of them will evaluate to 6, and therefore the function is continuous at x equals to 2. Okay, right. So the checking of continuity, as outlined by Chimaya, is just to check that this statement is valid. And then how do you know whether or not it's differentiable? We have to do it by calculation, you know. You have to first and foremost write down a definition. What is this, Chimaya? Right. And to calculate this derivative, we have to do it in 2 steps. Step 1, what must you do? The limit as it approaches 2 from the left. If it approaches 2 from the left, the function to use is x squared minus 6, and then over x minus 2. And then what must you do next? You must also find the limit as x approaches 2 from the right. From the right, it is 2x okay. Fill me in, Chimaya. For the first derivative, the left derivative, what does it work out to be? 4, is it? Okay, I take it from you. 4. The next one? 2, is it? Okay. And because the left and right derivative are not the same, we therefore conclude that this is D and E. And as such, B therefore is truly the choice. You must always remember, to check whether or not it is differentiable at a particular point, you really have to do the red color. You must do it this way. You cannot try to find shortcuts. You must refrain from using whatever shortcut they thought is valid. You have to refrain from that. Sinus, is it? Sinus. Runs in the family? Okay. Okay, for the next question, right? To sketch a possible graph of f prime x, I would like to invite James. Again, is it? He did this graph, something similar. Okay. Oh, he did the x log x. Okay, let's spare him then. Let's spare him. Okay, James, spare you because I did this book up for you. Spare. Let's have Lawrence. Okay. Well, Lawrence does it on the board. Can the rest of you do it at where you are? I'm going around the room to check. Yutong, have you drawn it? Okay, I think it looks. This FX. Hey, yeah, I think it looks good. It looks good. Yep. So can the rest of you try on the book now to draw the F prime graph? Chris, are you trying the F prime? Ah, nice. Yeah, save the tree.
But it's already printed, so apparently I just basically cut off.
Next chapter 3. Just printed.
All notes are already printed here. Even the assignment should be the one that you pushed.
Yeah, I dropped the assignment soft copy of the class WhatsApp.
Yeah, but it's already printed out.
Someone here told me I did give back your tutorial, assignment 1. Who in this class hasn't gotten back your assignment 1? Not sure. Okay. I didn't give it back. I'll go and search for it. I cannot find my bag. Okay. Let me take a look at some of your drawings. Stephen, you follow me out. Okay. So, still drawing. Okay. What thing for it? Nice drawing.
The graph only looks nice when it isn't sine 1 over x. Yeah, so for sine 1 over x, so for you design the graph they're on the left of the other. So towards the infinity, the sine you need to step on like whatever, but then towards 0 it becomes towards 0 the way becomes so dense it's just like
Okay, I see that quite a number of you got it right. So if I have to draw such a graph, the first thing I do is identify these obvious points that the graph must go through for the f prime. And then this side has a negative gradient. I therefore know that this portion here must come down. And then because to come back to red color, I must turn somewhere. And to go back to this red color, I know that I must turn somewhere. And so your graph will turn out with something like this.
Sinusoid.
It's not sinusoid.
Looks like.
Looks like. And then I mark in yellow color.
The inflection point. Because
Right. Hard to see, you know. Right. Okay, thank you.
When you mark the
Because this graph is quite bare, so you're supposed to draw them one above, either together or one above the other. That's okay. I think that's alright. Yeah, that's alright. Yeah, good. Thank you, Lawrence. Okay. So as we have already discussed, in the original graph, right? These points must have been inflection point, you know. Because these are the points where the gradient graph has a turning point. And you already know, no, to draw inflection point, one technique is for you to actually draw the dotted line first, the slanted line, then you draw the first part here, and then draw the second part. Then you can see really it's an inflection point. But it's kind of hard sometimes to try to draw the inflection point on the graph itself. It's not easy. Okay, that is question 3. Okay, for question 4. Okay, Kaita, you think you're ready, Kaita? You want to lead us to do question 4? How do you go about question 4? How do we want to achieve question 4? To do this part 1, right? Basically, we have to check whether or not, okay, Kaita, speak. To check for continuity is basically to check for this statement, right? So for part 1, we have to check the statement to see if it's true or false. Kaita, how do we do F0? Very good. So the F0, right? F0 is actually the 5x plus 3. And how do you do the limit? How do you do the limit? Limit. Right. Good. And then from right side. Of course, the class will organize the working nicely, you know, right? 0 plus 4 plus 0 minus 1 is again 3. Therefore, this is true. This is true. That it is indeed continuous at x equals to 0. The next thing is it differentiable at x equals to 0? To check for differentiability, again you gotta revert back to this sentence, no? You gotta revert back to f prime of 0. How do we evaluate f prime of 0? Limit x goes towards 0, f of x minus f of 0. Okay, Kaita, so from here what do we do? Right, you gotta find the left limit. For the left limit, right, for the left limit, the function to use is 5x plus 3, and this is 3. And this gives you an answer of 5. And then you can find the right limit. The right limit, you gotta use the other function. It's quite lengthy to write now. 3x plus 4 plus sine 2x minus cosine x minus 3 over x minus 0. Okay, Kaita, press on. How do you think we will evaluate the second one, this one? Okay, let's give Kaita a little bit of time. Okay, when you come across a function that's a bit messy, you know, harder, you want to hope that you can use the L'Hopital's rule. Kaita, can this question apply L'Hopital's rule? When x goes to 0, right? The numerator will be what? Right. So it's an indeterminate form. You can therefore apply the L'Hopital's rule once. You know what I'm saying? So if you apply the L'Hopital rule once, okay, let me write here again. If you apply the L'Hopital rule once, for the numerator, you will be left with 3 plus 0 plus 2 cosine 2x plus sine x whole thing over 1. And this gives me, when x goes to 0, you will have a value of 5. Right. So with this, we therefore conclude that the derivative at x equals to 0 is 5. Because the left and the right derivative are both 5, so therefore f prime 0 is also 5. That being the case, to answer the question, you therefore say is yes, and then you provide it with the working to justify. Yes. Cannot. That's not a valid step. You cannot just like that. After take limit on the left and limit on the cannot. Don't. This is something that I just can say.
So then what about this?
This to this line, I basically say this line is valid. There's no equal to 0. Is it equal to 0? Is it?
Yeah.
Don't have. The moment you differentiate, like you got to remove the equal sign. Yeah. So it's more, so at the point in question, right, at f prime 0, you really have to go through this process. Cannot take shortcut. Cannot. It's not allowed.
So the only reason for doing this here
It show you that.
Here, so that we can write this.
Yeah. Okay. I've written all over the question, but I'm sure you will organize it nicely to become a coherent, to give a coherent working, to support your conclusion that is continuous and differentiable. In fact, many times when you're asked to check for differentiability, you should not straight away go and check. You should check for first and foremost continuous. Okay. May I have a show of hands? Who have already tried question 5? Okay. So most of you have not tried. Why not give yourself that 2 minutes to at least try, so that it becomes more meaningful when we go through together. You did? Great. Chris? Okay, so for those who have not tried, maybe give yourself that 2 minutes, so it becomes more meaningful that you are trying ahead. Sure. Because the check for differentiability, normally the steps are harder. Normally. You're short of assignment. One person is short assignment 2, right? I have a soft copy in the WhatsApp already. I should give you a hard copy still. Right, yeah. I owe you a hard copy, assignment 2. Okay, let's discuss number 5 together. You are asked now, is f differentiable at x is 1? Okay, let's hear from Viresh and understand that you're the class rep. Right, class rep. Okay, Viresh, right? Okay, let's hear from you. How would we do number 5?
The two is, one is like just directly applying the left hand and the right hand derivative. And the other way is that because we just prove that the function is not continuous.
Brilliant. So let's do the second way first. Let's check it. Let's check the limit of the function as x approaches 1 from the left, and also the limit of the function as x approaches 1 from the right. Okay, from the left, Viresh, from the left, what's the answer? Right. From the right. So with these two, it implies that is not continuous at x equals 1. Therefore, f is not differentiable Okay. So in question 5, the shortcut is to check for continuity first. Okay, question 6. Question 6 is Kailash turn, right? Kailash will draw number 6 on the board while the rest of you try at your seat. Okay. Right. To draw the original graph, I think he did it rightly. He identified that at this point, given that the gradient graph changes from positive to negative, he therefore identified that it must have a maximum point over this region. At the same time, he also noticed that there is actually a change from negative to positive. So he identified, therefore, there must be a minimum point somewhere, right, around here. And then having marked these two, and then armed with courage, he joined them up nicely to become like this. And then once again, if I were to ask you to mark roughly the yellow point should be somewhere here. And that point is again the inflection point. Yep, he did it rightly. So that's y equals to f of x. Hey, these two look the same, interestingly. They look the same.
Just remember the end.
Okay. While you now look into question 7, allow me to go and look for the test dates. Let me go and check for the test dates. Thus, you're asking me about CT dates. Let me go and check.
Yeah, Mr. Tin.
Yup.
Would that be
GC used in the test. Test I think may not have, but exam sure have. Yeah, bye. Question 7 now. Okay, we're on to question 7. Shall we do question 7? Okay. For question 7, first and foremost, right? You want to establish that function f is continuous on the closed interval. Okay, why is it continuous on the closed interval? Martin? Since it is a polynomial, and then f is differentiable on, and for the same reason, no need, because it's a polynomial. You just state. Well, you don't have to so-called prove that it's continuous. You have to at least state, so that the marker knows that you know the requirements before you can use the MBT. Then say by MBT. Do you know the symbol? That exists. And do you know this short form?
Straight line.
Good one.
Such that.
Right, such that. Okay, so how do we evaluate this? This becomes 3c squared minus 7 equals to, what is f of minus 1? 6. What is f of minus 3? And then over 2. So therefore, do you know why I chose the negative root? Right. You must choose the c value that is within this range of values. That is 7A. Okay, 7A. Okay, still Martin, because Martin didn't say very much. Okay, Martin will stand by on 7B, okay? Martin is going to come to the front and address 7B, verbally, when you are ready. Okay?
No.
So the last time, was she very surprised? No.
Yeah.
She was. Okay.
Except for like 10 more minutes.
There was once, towards the end of the lesson, one girl asked to go to the toilet, so she went to the toilet. Then I told the class, let's vacate. We all ran out. So this shocked. Where are the rest? We all left the class. Next mission, right? You go toilet towards the end lesson, you come back with a big surprise. Okay, Martin is going to address the class on 7B. Martin, please. Right, he's right. He said G is not continuous on, so cannot invoke RT or Anyo, is there an issue there? Anyo, Hao Wen, is it Hao Wen and company? Is there something you can tell me? Hey, thank you for that. I was told that in Korean greeting, you just say Anya will do, not Annyeonghaseyo. No? Annyeonghaseyo is for the younger one to greet the older one, right? Yeah. Annyeong. Yeah. It's not Annyeonghaseyo for older people to greet the younger one. So next time I come into class, I just say Annyeong, and then the whole class will respond as Annyeonghaseyo. Is it how to do it? The teacher will greet the class as Annyeong. Is it? And the whole class must respond with the correct version. I was also told that even bowing, right? Bowing got different levels though. If a younger one bow to an older one, must bow more. And the older one bow to a younger one just a bit. True or not? Is it true? Is it a culture or is it Japanese culture? I get mixed up already.
Then all the way.
Okay. Okay, question 8. Okay, for question 8, I would like someone to come to the board to write down. Let's see. By popular demand. By popular demand. Okay, 8A. Let's even try writing out now. How do you write down the working for 8A? In their class, someone told me they are very confused with the symbol that they have to write with. I did, 7B? 7B I thought we talked about. Cannot. Thanks for being so attentive.
What is the notation in GOF?
Means division. Gx over fx.
Also G4 over F4 that then
let's see. Yeah, right. Yes. This is perfect.
Yay!
Yep.
Martin, you're perfect.
Yeah, this is the way to write down the symbol. Right. So you can now try to write down for the rest, no? Right, for the rest. Can you now try writing down for the rest? And then for this other one, there'll be and okay. Chen Hui, can you go to the board and write down 8C? 8C. Write 8C. No, the solution to 8C. Write 8C, you come to the board, just write 8C, go ahead. 8C. Chen Hui is going to write 8C for us, the solution.
Can you also be high?
Yo. Chen Hui, you're funny. Okay, the three boys are trying to entertain King Hui, right? Yep.
Why she's asleep?
Oh. Huh? 8-bit there?
So much.
Just plug it in, you know.
Oh, and then G2 is oh. Wait, that's so smart.
Wow, she's right. F inverse 2 is indeed 4. And then the answer is 4, right?
There goes 0 goes 1. There goes 0 goes 1. That makes 0 goes 1. They got a different approval for 0 goes 1.
You have to get hot water. You have to get a cup of water. Helps.
I don't know why.
You need hot water. Signer people always. I don't have, but I know lah. Okay. Remember someone was we were discussing about the so-called shortcut way to doing things. This question 9A is going to show you that it doesn't work. If you were to conveniently say, because when s goes to infinity, this thing dominates over this, and therefore you conveniently remove this x and say the answer is 0, it's wrong, you know. This question will prove us wrong.
Oh no.
Can you all now try this question and then see that it is not 0? Who has done it apart from Wen Yu? Wen Yu has done everything, right? Yeah. James did it as well. Okay. Okay. You 9C. 9C is like that, you know. can't use operator. It won't work. Okay, for asking 8C, now Aditi will march the board and do 8A.
A or no. Shouldn't it be 9?
Oh, 9 is 9.
Ding, 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 ding.
Bro, here. Bigger, bigly. So that they can see.
Wow, this is so smart.
We will start off with chapter 3, I think. Maybe maybe Monday lah. Monday. Chapter 3 on Monday.
I still don't understand this class. It's been 1 year.
It's been 1 year.
It's been 1 year and I still don't understand why they keep doing
They
it.
like the song, is it?
I don't know, they just randomly.
Okay, random song.
Damage level maximum.
Okay, the grade is getting high.
They are all very, very high.
That's correct, it's perfect.
Wow,
Yeah. Good. Yeah, good solution. Very clear, no? The solution is very clear. The handwriting is clear. It's big, you know? Yeah. Okay, that is 9A. 9B. That is grade task 2, no? Grade task 2 will be on 2 Mondays away.
I don't know what that is.
Today is the 2nd, right? 3rd, 4th, 5th, 12. I think 12 February. 12 February. 12 February. Okay, for 9B, right? 9B. Yen, what's going on, Yen? You got triggered by your friend next door, next to you. What are you talking about? Share the story. What's it about, Yen? Huh? The names, is it? Okay. After my lesson as well. Break, okay. I didn't give you an intermediate break, no. So I'm going to finish 10 and then we end the day so that you go a break. Yes? Number 10, I think 2 minutes can do the job. Okay? Because Christopher is going to do it. No. Okay, wait. Christopher, get ready. He will address the class. Yeah. It's nice for students to come to the front and learn to address the class like what Miss Koo was saying, public speaking. Just come to the front and address the class now. 안녕하세요. Yes, yeah. Oh, this one is it? Okay. Hey, the voting is over already, right? Voting. So you get in?
Results are coming out
Tomorrow. Okay. So hopefully you get what you want. Sure you get in. You didn't apply? You didn't. The boys can apply.
The boy applied then pull out.
Pull out. Reason pull out. Show support. Why? Oh. My daughter very funny, no. One day I asked her, why don't you just try to get into to become a prefect? She said no good, no. Prefect must go to school earlier than others, and you do wrong thing, you get scolding. She's very funny, no. Well, she's not wrong. She's very funny. I think she's gonna be a problem kid, you know.
My primary school they selected all the naughty kids as prefects, and I was
Really,
one of them.
You are. Okay, now the time has come for our friend here. His name is Christopher. How early you dismiss depends on Christopher and his presentation.
Run, Christopher, run. Run.
Okay, maybe I start the ball rolling for Christopher. Technically, as a language thing, right? Statement A is not wrong, you know, actually. It does have. Yeah. So technically, A is partially right, you know. No. Okay. Christopher, could you take the stand and address the class from B, C, and D, please? You can borrow my teaching instrument, you know.
When in doubt, choose C.
I know it's C.
Next question,
I just
choose
don't
C.
know why. I just don't know how.
Chris,
Next question.
are you ready? You come to the board and you can point and address the class. Come.
I'm not going to question yet.
Oh, you need time to prepare. But on the spot, it'd be more impactful. Shh. Class, let's give attention to Christopher.
I mean, honestly,
Wait, this single picture. Oh yeah.
To be a vertical asymptote, right? So Christopher is going to check on this now. Christopher will check whether or not the function has infinite limit. So Christopher can check this. Christopher, is this true? No, is this true?
it says x equals -1x.
It's false, right? I'm talking about option B. Option B. Yeah, it's false, right? Option B.
It's false.
Yeah. Okay, press on.
No, so that's actually
So B is up. Okay, Crystal, I have your B is up. Shh. Okay, B is up. So option C.
literally just like
Wait, what do you mean?
Some vanity thing.
yeah.
Vanity.
Yeah, okay.
Okay. So Christopher is judging things from the graph. He believed that the graph looks like this. I think maybe is yeah. I think should be like that. Should be like that. Should be like this.
Upside down.
Yeah.
Oh my god.
Let's change the direction.
What? My life. Insane, bro. What the X is I'm very sorry, I'm 3 hours of sleep
Okay, Christopher, maybe you can refer to my graph and address the class. Okay.
Wait, it's wrong to do that, Chris. You can't just change the direction of the y-axis because when x equals 0, it's negative 4, not positive 4.
No, I was gonna say that.
Like you need to shift the middle part. You need to shift the middle part up if you want to just look at.
Just draw an arrow.
Just draw it, bro.
Really? Okay, wait. Shift the middle part.
Okay. Right. Okay. Accepted is upside down arrows. It's okay. Press on. Of course not, Jethro. It's just to entertain you. That's why you do it this way. Thank you. I made a mistake.
No, this is like I do the okay, I mean like
Okay, now based on the graph, Chris, press on.
based on your graph.
Yeah.
Okay, like
Class, let's give our attention to Chris.
so like so C right, I think it's like well, the x axis is not for your you can see like over here right. X is like X the Y is like approaching zero. Y is approaching zero, sorry. Then X is equal to plus minus 1. You can see over there, you can literally see over here. Yes. And then D right is incomplete basically.
Right. Thank you, Chris. Thank you. Okay. As I told you, I did an intermediate break for you, so I owe you that. So therefore, we're going to dismiss the class.